Hello students, welcome to BTech first year physics course. In the last class, we have discussed about different types of constraint equation, and those are holonomic, non-holonomic, scleronomic and rehonomic constraint equation, right? Now today I am going to discuss mathematical analysis of constraint motion considering few examples. Okay, and you will see how to construct equation of constraint. Okay, now first example we will consider is pulley mass system. Here the two blocks are connected by an inextensible cable which passes over this pulley. As a result, the motion of the two blocks are interdependent. So here if we consider this block of mass m2 is higher than the block of mass m1, then naturally m2 will go down and m1 will go up with same acceleration because they are connected by this inextensible cable. So the motion of m1 and m2 is constrained or restricted, right? Now to analyze this constraint motion, first we have to write down constraint equation. So here constraint equation is this: z1 plus pi r plus z2 equal to L, where L is the length of this inextensible cable and z1 and z2 are the displacement of m1 and m2 at any instant of time from this fixed line passing through this center of the pulley, and here r is the radius of the pulley. Now as the cable passes over the pulley, the length of the cable over the pulley will be half of the circumference of the pulley, and that is pi multiplied by r, radius of the pulley. Right? Now, as the length of the inextensible cable is fixed, then z1 plus z2 will be constant. Now, differentiating with respect to time, we get this velocity relation between the two blocks. And the minus sign here signifies the opposite direction of movement of the two blocks. Right? So here M1 block is going up and M2 block is going down. Now differentiating the velocity with respect to time, we get this acceleration relation between the blocks. Now to find out the acceleration of these two blocks, we have to use equation of motion of individual block. Here T is the tension in the cable. So for M1 block, this is the equation of motion. And for M2 block, this is the equation of motion. Now if we add these equations, and as the magnitude of acceleration of M1 and M2 are same, we get these forms of acceleration of M1 and M2 block. Okay. Now next we will discuss block on a fixed wedge or inclined plane problem. And the wedge here is frictionless. Okay. Now here you can see the block is sliding downward along the inclined surface, right? So this is another example of constraint motion. Now to analyze this constraint motion, first we have to write down constraint equation. So to do that, let's consider the block is at this position at a particular instant, and these are x and y-axis of this Cartesian coordinate. Now here the total height of the wedge is h and L is the length of the base of the wedge. Then the constraint equation will be like this: y plus x tan theta, which is this height, is actually will be the total height of the wedge, and that is constant, right? So thus we can say the position of the block will change and accordingly x and y will vary, but the total height of the wedge, that is h, remains same, which is the addition of these two terms, right? So then we can write this equation of constraint: x by L plus y by h equal to 1. Now if we differentiate this with respect to time, we get this expression of velocity, and this is the relation between x component of velocity to y component of that, right? Then differentiating again with respect to time, we get this relation between x and y component of acceleration. Now the y component of acceleration is actually gravitational acceleration, which is minus g, because here this block is sliding downward, right? So the y component of acceleration will be minus g. Okay, thus we obtain the x component of acceleration, and the expression is like this. Now we want to find out the acceleration along the inclined plane. Okay, so to do that, let's draw the ax and ay component. Then we have to find out this component which is perpendicular to the inclined plane. Now the acceleration along the inclined surface can be obtained from this equation. Okay, so that is the value will be g sin theta, that is along this inclined plane, right? Now let's discuss another example, and that is block on an accelerated frictionless wedge. Here the angle of the wedge is 45 degree and acceleration of the wedge is capital A, that is towards the right. Now we have to find out the acceleration of the block with respect to ground. Okay, now let's write the constraint equation. As here tan 45 degree is 1, and at a particular instant, suppose after t time, the distance covered by the wedge is half multiplied by acceleration multiplied by time squared. Then the equation of constraint will be like this. Okay, now if we double differentiate this equation with respect to time, then we get this relation of x and y component of acceleration, that is ax plus ay equal to capital A, that is the acceleration of the block. Now if we divide n component along y and x axis, we get this equation of motion, and after that we get this expression of n. Now using this expression of n, we can obtain the x and y component of acceleration of the block like this. Okay, now here one interesting phenomena will happen. If the acceleration of the wedge is greater than gravitational acceleration, the block will climb up instead of sliding downward. Okay. So I hope you have understood how to do mathematical analysis of any constraint motion using the concept of equation of constraint, right? Okay, so today we will stop here. In the next class we will see different types of system of mass particle possible and some important theorems which governs the dynamics of mass system, not going into any mathematical description. Okay, so thank you for attending today's lecture. See you in the next class. Stay tuned.